now, inshallah. Yes, now it will work. Okay, so this is your question number one. That question is from General Physics Part 1. I mean, first question in your theory paper is mostly from kinematics, work energy, power, and momentum mixed together, right? And forces as how somehow. Okay, so we have to have a good grip in all these topics to overcome the problems, and definitely we have to solve these all uh, in a good way ताकि हमारा maximum result आ सके, output आ सके. So let's talk about an aeroplane of mass 2.5 into 10 raised power 5 kg lands with a speed of 62 meter per second on a horizontal runway at time t is equals to 0. The aeroplane decelerates uniformly. These all are the very important points what I highlight here, and travels along the runway in the straight line until it reaches to the speed of 6 meter per second at t is equal to 35 seconds. So this all information is very, very important for you for your question. Calculate the deceleration of the aeroplane in 35 seconds after it lands. So for your deceleration, this is of 2 marks question. 1 mark is either your formula or the values you plug in instead of formula, and 1 mark is for the answer. Okay, so देखो what will I do? I will say that deceleration is equals to v minus u divided by t. And what is final speed? 6. What is initial speed by which it landed? Calculator ready rakhna hai. 62. And what is the time taken? Time taken is 35 seconds. So what will be your answer? Do you have a calculator? Yes, Mariam, are you there? Mariam, are you there? And do you hear me? Okay, let me open up my calculator. Meanwhile, yes, here is that. It is 6 minus 62 divided by 35. That is minus 1.6. It is minus 1.6. So when it is deceleration, I will not use this minus. Till this, you got 1 mark. And here you will write the answer, and that answer will be basically your 1.6. Unit is also not given to you, so when you will write with units, you will score the mark. Then the resultant force acting on the aeroplane, when you are going to talk about the resultant force, that force is equals to mass times acceleration. So mass is given to you 2.5 into 10 raised power 5 kg times acceleration is 1.6. So I believe that 2.5 exponent 5 times 1.6. So your answer is 4,000. It is actually 4,000 again 1,000. So you will write this number as 4.0 into 10 raised power 1, 2, 3, 4, 5, 6.
So then this
6.
is 4 million, right, sir?
Yes, this is for million. Welcome to the class.
Thank you, sir. I just came back from giving my math paper 4.
Oh, how was that?
It was okay, sir. Alhamdulillah. Just make
Alhamdulillah,
sure.
Alhamdulillah. No, no, no. Inshallah, it would be very good. Okay,
Assalamu
so
alaikum, sir.
Walaikum Salam. Khadija, are you
I'm
back?
no, sir. It's me, Mariam. I'm sorry
Where
I
is it?
left in between. It was a net issue, so I'm sorry for
Okay, okay.
that.
That's why I was calling you calculator, calculator, calculator. But no one
I'm
was there with
sorry, sir.
calculator. It's
I'm
okay.
sorry.
Hmm? No more sorries. Okay. So, Ariba, I will talk to you about the paper in detail,
Okay.
but after this completion of the class. Okay, so
Okay,
this
got
is actually the question. If you have, if you join me right here, I can give you the clue that there is an aeroplane of mass 5.2, sorry, 2.5 into 10 to the power 5 kg. It lands with a speed of 62 meters per second. So it is its u, and at the runway, at time is equal to 0. It decelerates uniformly and travels along the runway in the straight line. Straight line means there is no change in gravitational potential energy. This indicates this thing. And at time t equals to 6 second, sorry, and it reaches to a speed of 6 meter per second. That is its final speed. So I can make it v. So v is given to you. So if v is given to you and the time is 35 seconds. So the first part is calculate deceleration. What is deceleration? Deceleration is same as acceleration with actually by formula. So a is equals to v minus u divided by t. So v is 6, u is 62, and time is 35. So you got 1.6 meter per second with negative sign. But when you declare it is deceleration, so deceleration itself is negative. So that is why your deceleration will be cancelled by negative sign, and you will only write plus 1.6 meters per second square. Is it good? Is it clear to you?
Yes, sir.
Okay, the next is the resultant force acting on the aeroplane as it decelerates. So again, it's very easy question of 2 marks. 1 mark is either for formula or to plug in the values. So I will suggest that it will be 1C. You will score here if you put F is equals to MA, or instead of F is equals to MA, just put the value of F and A, and 1 mark will be awarded to you here. That will be your answer mark. Okay, so I believe that you people, I believe that if you people will be aware of scoring the marks, you will be able to score it, otherwise no. So here I put two significant figures because in my data all the data is consisting of two significant figures. That's why I put not 4 into 10 raised power 6 newton. I just put 4.0 into 10 raised power 6 newton. So it is 4 million newton force acting on it. Is it? Is it clear to all?
Yes, sir.
Okay. Then the same question is entering in the momentum. Dekho, it is started from kinematics. This part is your kinematics, right? Then you move to forces or Newton laws. Then you move to dynamics. So this is actually in theory. So if you do not know one chapter, you will be able to you will not be able to score the marks. So here the momentum of the aeroplane when its speed is 6 meter per second. So again 2 marks question. So it means one formula is 1 mark is for formula R values. So P is equals to M times V. So mass is 2.5 into 10 raised power 5. And what is speed? 6 meters. So it would be 2.5 times 6. It would be 15 into 10 raised power 5 Newton second. Or you can use your answer as 1.5 into 10 raised power 6 Newton second. Got it? So this will award you 2 marks.
Got it, sir.
Okay. The next is again kinematics, this part. So just see how drifting that is. In physics, students are not allowed to drift at the road, but examiner is allowed to drift in the paper. Okay, at time t is equals to 35 seconds, the aeroplane stops deceleration. Very important information that it stops deceleration and moves along the runway at the constant speed, right? For 6 meter per second for next 15 seconds. So this is again really, really important information. And with the help of that information, you people will be asked some further calculations or further graph. So if it is clear to you, on figure 1.1, sketch the shape of the graph for the distance traveled by the aeroplane along the runway between time t is equal to 0 to time t is equal to 50 seconds. You are not required to calculate the distance values. Wow. Examiner played a very smart card, that instead of just putting the student into calculations, just award 3 marks and just make the game over. First of all, first of all, I would like to ask you people, are okay, I don't ask you people, just I will tell you it's my day today. I will ask you later on. So if you have distance and time graph and you want to draw the decelerations, and then you will, your graph would be having this pattern, decreasing gradient, because the gradient of displacement and distance and time graph, that gives you velocity. So if gradient decreases, it means velocity decreases, and that is your deceleration. Is it? Do you believe that?
Yes.
Okay. Then the next part is constant velocity. So as I told you that gradient of displacement time is velocity. So if you have to make it again, then your gradient should be constant, and constant gradient is this one. Its gradient is constant. Its gradient is constant. Right? Do you believe this thing? But the problem is, till 35 seconds you have to draw a curve, and after that your curve should become a straight line. So for this graph, what I recommend to the students, that is, just take your scale and draw a straight line from indicated time, let's say from 35 to 50, and then join this over here. So if you're going to join this over here, did you see there is a hub, there is a point clicking point generated. That's why I just recommend the students to draw the opposite graph, right? I mean, drawing, start drawing from end and just finish it to the start this way. So that is a curve. So here I have I have shown you one thing, that if you will keep your line as higher as possible, and similarly like this, if its gradient would be kept as more steeper, then it would be more easy to make a curve or to show a curve like this. Is it? So you can simply say that I will join this here, but I will not change the angle of the curve beyond this point, this way. Did you get it?
Yes, sir.
So this, from this point to this point, this shows constant speed, and beyond that it shows deceleration. So because calculations are not required, so whatever you did, all are correct. Okay, is it clear to you?
So how are the marks divided? Like you get three
Yeah,
marks on
the
this?
marks will be divided in this way. If this is 1 mark, short straight line, then 1 mark is for curved line, curved graph, right? This area beyond this, from 35 second to 0, and one more mark is to provide a smooth relation between deceleration point and constant velocity. Most of the time student used to do that. I'm just going to draw, you know what I drew initially, ऐसे student draw कर लेते हैं, ठीक है, and for example they draw it like this. Most of the time students get this problem, right? So it will award you 2 marks only, but the upper one, it will award you 3 marks, and this one will also award you 3 marks. Is it clear to you?
Yes, sir, got it.
Clear to everyone? Ariba, and if Khadija has joined, then Khadija also.
Sir, Reba is currently not in the class, so
So you are the only in the class.
kind of,
One and
yeah.
only. Okay. So as the aeroplane decelerates, its kinetic energy decreases. Now just check. He has switched to work energy and power, isn't it? So how many chapters he has covered in one question? One, two, three, and four chapters. इसलिए journal physics is journal physics. Anything can be asked to you. Okay. Now, as the aeroplane decelerates, the kinetic energy decreases. Suggest what happens to this energy. So, what is your suggestion? The kinetic energy.
Sir, would it be lost like as thermal energy or something?
Yes, exactly. Because the aeroplane is applying the brakes now.
Yeah.
So, that is converted to thermal energy of braking system.
So what if we don't write the braking system thingy? Will we
No,
lose a
no
mark?
matter, no issue.
Oh, okay,
It
thank
is
you.
not mandatory. It is not mandatory. Okay, this point to this point. Is this clear to you?
Yes, sir.
Go to question number two. Question number two seems to be starting from extension, but definitely in extension, we need some force, we will have some energy, and all that stuff. It means that this chapter will be, or this question will also include multiple topics. This will also include multiple topics. Okay,
Okay.
just a second. No. So, this is a figure 2.1 is the extension load graph of a light spring S. Okay, extension load graph. So it is starting from 0, 0. If it would not be extension, if it would be load and length graph, so it would never start from 0, 0. So this is its beauty that it starts from 0. And this is straight till this point. So this straight section, I'm when I see a question, I used to, recall everything related to that topic, what comes to my mind, or what I have learned. Then I will be, able to handle that question in a proper way. So state section is basically following Hooke's law, isn't it?
Yeah.
Okay. State the range of load for which it obeys. So, what is the range of the load? Load is mentioned on x-axis. So, you must write that it is from 0.
To
If
8,
it is
right?
not obeys Hooke's law, then it would start from 8 to 10. But because it is obeys Hooke's law, so we have to start from 0 to 8 Newton. Is it clear to you?
Yes, sir. Got it.
Okay. The next is use the information, this information, to determine the spring constant. Very interesting question. I have told you that if you have this graph, okay, load and extension graph, load and extension graph, you people can find it. There was a one more. You people can find the gradient. If its gradient is given to you, what you can have its spring constant. Gradient is equals to E by F, right? But your spring constant is F by E. You know, F by E is basically what? Force over extension, or F upon X. So here, what will you do? You will take the gradient and then you will just take its inverse. Why? Because extension is at the y-axis and load is at the x-axis. So there is an easy way for that. Easy way for that is just find the value of load anywhere, wherever you are convenient. At this point, we can find the value of load, and for that value of load, just find the corresponding value of extension. So what is corresponding value of extension? That is na, so 10, 11, 12, 13, 14, 15. So it is 15, and you have to see the unit also. So it is 15 centimeter. So if you write that k is equals to force divided by extension, then for 8 Newton, it is 15 centimeter. So you can simply write 0.15. So what will be your answer? It will be 8 by 0.15. So it is 53.3, right? 53.3. And you will write the unit also because he has not mentioned unit. So its unit is Newton per meter. So your final answer should be not exceeding two significant figures. It is 53 Newton meter minus 1 or Newton per meter. Okay? Did you get it?
Sir, got it.
Okay. So this is now, oh wow, wow, wow. We have just gone through this topic as well, series and parallel. A second spring, identical spring of S, is attached to the spring S. Now two springs are attached to a rod as shown in figure 2.1. The load of 4 Newton, the load of 4 Newton is attached to it. How much? 4
4
Newton is
Newton.
attached from the bottom of the spring S, and arrangement is shown to you, right? What is that? The arrangement is shown to you. You will
Like
keep two?
two springs connected to. So is the
Yes.
load divided on each spring or like?
No, 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 no. If it would be divided if they are parallel. It means the force exerted by this, it is 4 Newton. Na? It will
Yeah.
exert this 4 Newton force on this one, and that 4 Newton force will stretch it downward. So overall, the force is 4 Newton throughout, right? Where is the force? 4 Newton. So that is in equilibrium. State the name of form of energy stored in two springs when they are stretched. So what is the name of that energy? Either you can write
Elastic.
elastic potential energy, okay, or you can name it strain energy. Okay, is it clear?
Yes.
Okay, then determine the extension of the arrangement in figure 2.1. Wow, what a question. It should not be uh, just, I mean, if we do not have graph, then it would be hard to determine it. But as we have graph, so we can determine it. Either way, right? As we have graph, so from graph it is quite easy. Okay, now check. Go to 4 Newton load and find what is extension there. Okay, from this graph, go to 4 Newton load and find out the extension. This is 4 Newton load, and extension is how much? The extension is 10. So 10 is the extension of one spring, isn't it? Are you getting it? What is extension of one spring? 10 Newton. So
Sir,
when
but
two springs,
it's not exactly 10, right?
it is 10 centimeter for one. Okay,
But like, wasn't it 9 or 8 point something, like, up?
was it?
Because you extended the line a little bit above
Oh my
the
God! Yes, yes,
actual
yes, yes,
line.
yes, yes. Yes. Sorry, sorry, sorry. I just grown old. I did not knew that it is ending here.
8. So it will be, I think, 9 and 8, and it will be 7.5, something like
7.5. Yes.
that. Oh,
Okay. So it is
yeah.
7.5. So the extension is 7.5 for single spring, right? Is it clear? So this spring will get extended by 7.5 centimeter. Similarly, this would get an extension of 7.5 centimeter. And examiner wants from the student that the student must add these two extensions combinedly. This is the word of arrangement, not of a single spring. So it would be, you will write 7.5 plus 7.5. So it will be 1.5 centimeter, because unit is given to you. So it just 1.5 is enough to write.
Okay, got it.
Got it.
So whenever it
The
says arrangement, we have to add both of them?
No, if it would not be, if it would be determine the extension of the spring. Yes, springs. So there is a difference. If it is said that if a spring, it means we have to find the extension of a single spring. No fighting. Okay. And
Oh,
if it is said that extension of the arrangement, तो आपको ये करना.
got it.
The next is the load is carefully released, increased to 6 Newton total. Where what is the level of the load? It is increased to 6 Newton total load. Calculate the distance moved by the load to the new equilibrium position as the load is increased from 4 to 6 Newton. Wow, what a question, man. Now you will go back to 6 Newton. Did you understand the question? That it is 6 Newton is the new load. So when the load is 6 Newton, this one, okay. Oh, again I have just increased the line. So that is the extension. So what is the extension? It is 10.15, isn't it?
Yes, sir.
Mm, just let me check. It is almost 10. If I connect it over here, yeah, it is 10. 11. Sorry. Not 10. It is 11. Okay. So before that, it was 7.5. 7.5. So what is the new extension in each spring? In each spring, the extension is 10 minus 7.5, which is how much? 2.5 centimeter. Is it?
Yeah.
Got it. So each spring will be extended by 2.5 centimeter. So new extension is 2.5 plus 2.5, which is equals to 5.0 centimeter more than 1.5, isn't it? Oh, no. I just made a mistake here. 7.5 plus 7.5 कितना होता है? तुमने भी नहीं मुझे बताया यार. It is 15 centimeter. ठीक है?
Oh, okay. Sorry for that.
Okay, no problem. So 15 centimeter. It means how much distance moved? This much.
How is it more than 15 centimeter then?
देखो, already it was extended to 15 now, combinedly.
Hmm. Oh, so 5 centimeters more, so 20.
5 centimeter more is covered. So the total distance covered is how much?
20.
5 centimeter. यानी total extension is 15 now, है ना? अब आपकी total extension कितनी होगी? 15 plus 5, 20. मैं यहाँ पे लिख देता हूँ. Total extension is equals to 20 centimeter, right?
Yeah. So, but wouldn't
20
that
नहीं,
be
नहीं,
the
नहीं, just a
length?
second. No.
Length?
I just made some mistake. Wait. Calculations. I need help in calculations. That new extension is the total extension is not 20, it is 22, because extension due to one spring was how much? 11. Na? At 6 it is 11 centimeter, isn't it?
Yeah.
So yes, I made a mistake here. I just subtracted from 10 from 7.5. It was 11 from 7.5.
Oh,
So
okay.
11. ठीक है ना? So it is basically 3.5, 3.5, that is 7.0. Right? So it means it is extended 7.0. Yani it will move 7.0 centimeter down. But the easy way to handle that is, what is the new total new extension? Total new extension is 11 is for 1. So 11 plus 11, it would become 22 centimeter. Right? So new extension is 22 centimeter. What was the old extension? Our previous extension, that was 15 centimeter. So what is the difference? What is the difference? 22
5.
minus 15,
No, not 5. It's more
7
than
meter,
5.
7.0 centimeter. ठीक है?
Yeah. But sir, the new extension, like the total extension, is it at the total length of the spring, right?
Total length of the
After
spring
extending?
after extending. देखो ना, at 6 Newton, what is the total extension of the spring? 11. Extension है ये, length
11.
नहीं है.
Oh, acha. Okay.
Got it?
Oh, yeah. Yeah. Oh,
So
yeah.
this
I got
is basically your question number 2. So did you see that how we got twisted? ये मैंने उधर भी मना किया था कि you will not do like that. So next two questions are from thermal. This one is there, pressure. Let's try to solve it until
it. This was
that
also in the
barometer.
topical. I saw.
Yeah, that was also in the topic. That figure shows the gas trapped in the sealed end of the tube. Okay, and a denser liquid is also there. The the scale marked on the sealed end of the tube is calibrated to read the volume of the gas trapped above the liquid. Initial, oh man, you have to do that because it is gas volume. The volume V1 of the gas is 60 cubic centimeter. The pressure of the atmosphere is 1.0 into 10 raised power 5 Pascal. This is the extra information, and you have to keep this information with you when it is given. It is really, really horrible. State how figure 3.1 shows that the pressure of the trapped gas is equal to the pressure of the atmosphere. Check this one out. Because here is the atmospheric pressure acting. Okay?
There's an open end.
Yes, this is the atmospheric pressure. Atmospheric pressure. So when it is atmospheric pressure, it means the liquid pressure is cancelled out on both sides. Is it? What is the liquid pressure? Liquid pressure is cancelled on both sides. If it would be something like this, up check karo. Now there is a liquid pressure of this much. This is actually the liquid column, and at this point, the pressure of liquid plus atmospheric pressure both are there. This is the total pressure. Right? Are you getting my point?
Yes, got it. But like,
Okay.
isn't it just
बोलो
the
बोलो.
pressure of the liquid? Like,
No.
the
Atmosphere
atmospheric
is now
pressure
here.
comes
No?
from the open end?
Open end, yes.
Oh, okay, okay. Then got it.
Got it. It means here only atmospheric pressure is there. Only atmospheric pressure is there. So you will say state how figure shows that pressure of the trapped gas is equal to pressure of atmosphere. So you will say that the liquid pressure is, I mean, the pressure of the liquid is cancelled out from both sides. Pressure of liquid is cancelled out R. The height of liquid is same. This is second option. Our second answer, height of liquid is same on both sides. So that density, so the pressure. So all of these things are actually involved in it. So actually at this point ना मैं ये जो border line मैंने draw किया ना, at this border line the pressure is from this side, right? And the pressure is from this side. So if it is in equilibrium, this is the pressure of the gas plus pressure of the liquid from this point to this point. Got it? And over here, the total pressure is pressure of atmosphere plus pressure of the liquid from this side to this side. You know, density is same, value of G is same, and height is same. So does it mean that of liquid same on both sides? Is it not? Explain in terms of the movement of the molecules why the trapped gas exerts a pressure on the walls of the container. So I explained it to you in detail that the gas molecules collide with each other and with the walls of the container, isn't it? The gas molecules collide with each other and with the walls of container. Are you there? So
Yes, sir.
their momentum is changed. When their momentum is changed, it causes force. It causes a force acting per unit area, which is equal to pressure, which results pressure. Is it clear to you?
Yes.
Right? This is what I told you to recall. So this is again I'm saying that recall it. Okay. The next is that the more of the dense liquid is poured into the open end of the tube, the level of the liquid surface on both sealed and open ends of the tube rises. Okay? And the temperature of the trapped atmosphere gas remains unchanged. It is constant. Okay, this is 2 mark question. In the sealed end of the tube, the volume is now V2. The trapped gas is 50 cubic centimeter. The open end of the tube, the liquid surface is 15 centimeter above the level of the sealed tube. Calculate P2 of the trapped gas. So, when you are going to calculate P2 of the trapped gas, you know, here gas laws will be applied. P1 V1 equals to P2 V2. I think if I have not just overlooked the question when I was assigning you the topical, I would never leave that question because that all involves the things we have studied. So P1, pressure 1 was the atmospheric pressure only. You have to calculate P2, so you will make subject P2 here. It will be P1 V1 divided by V2. Okay,
Yes.
so I can say that is P1 is atmospheric pressure, so it is 1.0 into 10 raised power 5. I told you, na, this is the horrible information. 1.0 into 10 raised power 5. So it is 1.0 into 10 raised power 5 into V1 was given there. I think here it was 60 cubic centimeter. So it is 60. No need to convert centimeter because V2 is also in centimeter divided by 50. So please calculate it for me. Yes.
Sir, do I calculate it or?
Yes. 6 divided by
Okay.
5. 6 divided by 5 is
Just a second.
1.5. 1 point, 1.2. Sorry. 1.2 into 10 raised power 5 Pascal. So you will write 1.2 into 10 raised power 5 Pascal. This is your answer. For 2 marks, you have to do that. Then it is said that calculate the density of the liquid of the tube. So just check the tricky nature of examiner. He has not asked us to calculate the pressure. He asked us to calculate the density because he knows that the student will be able to calculate the pressure is equals to rho gh. This is the formula, and P is the same as this one because that is also again in equilibrium. Okay, so it is 1.2 into 10 raised power 5 is equals to density into value of G is 9.8 into what is the height of the liquid column? 15 centimeter. 15 centimeter means 0.15. So it is
15
0.15.
centimeter.
Yeah, 15 centimeter. Na? Here it is.
Oh, acha. Okay.
ठीक है,
Let's
कैलकुलेट
looking at
करिए जरा
something
डेंसिटी.
else.
From here density is equals to 1.2 into 10 raised power 5 divided by 9.8 into 0.15. So what did you get?
1.2 into 10 to the power 5 divided by 9.8 into 0.15. Okay, just a second. 80. I got a very big value. It was like 81,632.
81,632.
32. Yeah, there are point 2, but I think this is enough.
Okay,
Is it?
that's fine. Yeah, it is enough. So you will write 8.2 into 10 raised power 1, 2, 3, 4. 8.2 into 10 raised power 4 kg per cubic meter. Got it?
Yes, sir, got it.
Okay. You clear to you?
Look it up. Yes, I got it, sir.
Yeah. I now that you are tired after these much calculations alone in the class, but
No, sir, there's a Reba with me. She rejoined.
आप इसको यूं भी कह सकते हो. It is 82,000.
82,000?
Yes.
Okay. So the the
Number
exact
of
doesn't
significant
matter.
figures are two. Still two.
Oh, okay. I get it. Yeah.
Got it.
Yeah.
So this was basically your general physics part. I'm going to save it and I will send it to you.
Sir, do you have a
Inshallah.
list of tricky questions?
Yes.
You do? Can we please do that?
अभी नहीं वो अभी टाइम लगेगा थोड़ा तुम्हें ट्रिकी क्वेश्चंस के लिए टाइम करने में. सो आई विल बी देयर इंशाल्लाह विद यू फॉर यू. वहां पे हम करेंगे कुछ काम.
Hmm.
ठीक है.
Okay.
मैंने टेस्ट के लिए भी तो रखने होते हैं ना.
Oh my god.
यस. सो general physics questions. Okay ji. Is there
Yeah.
anything you want to ask me?
No, sir. But like, so can you share the test schedule and stuff, like the topic division and everything?
Yes, yes. Today I will make it and then I will share it to you. If
Okay.
not today, then inshallah by this weekend, inshallah.